we're going to talk about what is a function. So we're going to talk about the definition of a function. We're going to talk about representing functions using words, tables, graphs, or formulas. We're going to do function notation, which you've seen a little bit of, such as y equals f of x. Have you seen a little bit of that? We're going to talk about a relation versus a function, and finally the vertical line test. So first of all, what is a function? A function is a rule which takes certain values as inputs and assigns to each input value exactly one output value. That's very important, that you have exactly one output for every input. The output is a function of the input. So, to simplify this, a function is a relationship between two quantities. You see that when you graph, because you graph things such as x and y, so it's a relationship between two quantities, and each input item is assigned exactly one item of an output. Let's look at the notation first before we get into everything else. First of all, you need to look for the words is a function of, because that will help you. Those words right there will tell you. So if I said Q is a function of the quantity T, we can actually write a math sentence. Q is equals is a function of T. That is not F times T, it's a function of T. And because this is our input, and this is called the independent variable, meaning I have a choice to put that in there, that means Q is our output, or it's our dependent variable. It's dependent upon what is inside the parentheses. So if I were going to write this as a point, the point would be input Q, output Q, input T, output Q. So this is like in our X spot, and this is in our Y spot. If we were going to graph this, since the T is in the X spot, the T would be down here, and the Q is in the Y spot, that would be there, especially if you're graphing in quadrant 1. So it's always good to make a point out of it, and then you can understand what the independent variable is and the dependent, or the input and the output. Things you'll hear people say, Q is a function of T, or you'll say Q equals f of T. They mean the same thing. Again, here's our function notation, and I kind of put in what I've already talked about. Input is in the X spot, output is in the Y. This is independent, this is dependent. All right, let's use words first. The number of gallons of paint to paint a house is dependent on the size of the house. Okay? So the gallons of paint depends on the size of the house. So if this depends on the size of the house, I know the size of the house is independent. I can pick any house I want, and then I can figure out how many gallons of paint I need. A gallon of paint typically covers 250 square feet. Thus, the number of gallons of paint, N, so this is gallons of paint, N, they want us to call that N, is a function of, they kind of tell you, the area, and they're letting you use an A to be painted. So, let's make a math sentence out of this. So I can say the number of gallons of paint is a function of the area. Here I have this written. This is my independent. So I always tell everybody to label the crap out of it. So A stands for area, and my units are in square feet. N stands for number of gallons of paint. So the point that I would have would be the point A, comma, N. So if I was going to graph this in quadrant 1, area would be here, and the number of gallons of paint here. And this is feet squared. You always want to have the units. And this is number of gallons of paint. So let's explain in words what this statement means. So here I have a math sentence, and now that we've labeled the crap out of it above, I know this is the area in square feet, and I know this is the number of gallons of paint. So I can say this in words now. You can say it left to right or right to left, but let's go right to left just for something different. It takes 40 gallons of paint to cover 10,000 square foot area, or a house. You could also say a 10,000 square foot area requires 40 gallons of paint. They're both the same. You can say it either way, but that's how I want you to take the words and make them into, or excuse me, the math and make it into words. Okay, now let's look at a table. Now I have M equals M of t and G equals G of t. So they're kind of telling you I've got two sets of points. I've got the sets of point Tm and the sets of points Tg. So they basically are using this column twice because I've got some sets of points going here. Here's a set of points, here's a set of points, here's a set of points. And then I've also got, here's a set of points. So the month is being used for two different things. Now if you'll notice, the time is independent, which is usually typical. And the milk prices and the gas prices depend on what month we're talking about. So in order to fill this in, if I want to figure out what M of 4 is, I know this is the time or the month. So I come over to 4 right here and I'm looking for M. So I know that M of 4 is 2.07. Then I said if M of something is 210, I can come over here. So M of what is 210? Well, M of 3 is 210. And also you can see that M of 5 is also 210. So I have 2 months where the price of the milk is $2.10. Now G of 6. Okay, so this still stands for time. I come over and look at the 6 and come down in the gas column and I see that's 256. I should probably put dollar signs with all these things, so let's do that. Now G of what is 265? So I come across and I see right here G of 2 is 265. So you just used inputs and outputs with a table. All right, now let's talk about having something be a function or not. So I want to know, are M and G functions? Well, remember, for every input, which is our x value, I have to have just one output. And it has to be unique. So in this case, I've got Tm and I have Tg. So I just got to make sure that for every time that I have, that it has only one output. So let's look at the M's. I have 1 here, 2, 205, 3, 210, 4, 207, and then 5, 210. So people look at this and say, wait a minute, look what I have. I have a 210 here. However, because your x's are different, you can have the same y as long as your x's are different. So that's okay. So all right, cool, that works. Now let's look at the gas. And I look at this. It looks like every input has its own output. So yes, are they functions? Yes, they both are. Now, they're going to ask you some other. Is G a function of M? So is G a function of M? See how I wrote that into a math sentence? And then I know the point is mg now. So this is my x and this is my y. So I'm looking at points like here, here, here. And I look at them. And I'm doing okay. And I'm going to leave these two circled here. This is where g is not a function of m. Because see how I have the same x value having two different y's? That you can't have. So no. This is not a function because I have this. That's one point, and the other point is here. See how my x's are the same? They can't be. You can't have two different y's for the same x, so this is no. The next thing is they want to know, is m a function of g? Is m a function of g? So my point now is gm. So if I look at it here, I've got this, the points are now going this way. See how it's going this way now? This and these two are different, but they have the same y, but that's okay because this is where the question is. So this is, yes, this is a function because my x's are different or my inputs are different. Now, how do I tell if a function is a function? And we math people are lazy. We like to come up with tests, and we figured out that there's this test that for y to be a function of x, each value of x must be associated with exactly one value of y. That's what the definition of a function is. So they came up with a vertical line test. So if I draw a vertical line going up and down, if I cross more than two spots, then I realize that my input has two different outputs and you cannot have that. So it's a cool test to do, and you can check very quickly to see if it's a function or not. So let's look at these right here. So as I look at this, if I draw the vertical line test here and here, I see where it's crossing in more than one spot each time. That means, like, for example, 2 has 2 different y's, then it's not a function. So no, this is not a function. I put an exclamation point here if it lets me. If this is a parabola, so if I draw my vertical line test, I say, oh yeah, that's okay, that's good. A line, yeah, that's good too. Vertical line test, yes. And this is a parabola on its side. No, it passes more than one time. So the vertical line test is very useful because you can look at a graph very quickly and tell me if it's a function or not. All right, this is an introduction to functions.